One last type of network, and the most famous networks for image analyzing is the convolutional neural networks. So the main difference is that the types of layers of neurons that we have seen so far are called dense layer neurons, where all the connections between the neurons are possible. And one of the problems with this, with information that has a very large spatial correlation, is that there's an over adjustment. So I have a large amount of neurons to do adjustments, and by doing this, my model has the trend to over adjust. So how can we avoid this? We can use spatial correlation. This was already known in image analyzing for these convolutional models. So the base of this is that I'm not going to have a weight or a connection from one neuron with all the other neurons that are close. But instead of that, I'm going to establish a window, a kernel, and this window will establish the weight. So for every neuron is going to be related to another one just in this small window. So I'm going to keep things nearby. The spatial proximity component is the one that's going to allow me to reduce the number of parameters, meaning that I don't have to adjust anymore. Let's say if I have 5 by 5 here, I'm going to create another layer that has 5 by 5. I would have 25 times 25 neurons. But if I have a kernel that's 3 by 3, then I'd only have to adjust those 9 neurons. This is going to be a lot faster. So the idea of the convolutions is to slide this window on top the others to create the results that are going to be in the new layer. So this is a little bit more advanced than the neural networks. For tabular data, it's not used that often because there's no need to do it. If you have data with correlations, with spatial correlation or temporary correlation, then it becomes a little bit more common to use them. And especially if you're using satellite images or for different processes, and it's very common to use this type of tool since it's very effective with this type of data with spatial correlation. This is another example. So we were seeing before with just with one layer. For the spatial data from satellites, it's very common to have 3 layers. So you have a layer here, that's the red, the green, and the blue. Then my filters here are going to have a weight for each one of these layers, or it can be shared for the different layers, depending on what can be more interesting for you. The main message is that the neural networks that are convolutional are a more advanced tool for neural networks, and it's generally used whenever there's data that's correlated. And with this, the weight is shared in this window, and you just have to adjust the weight for each one of the neurons, the input neurons. Something that's this is not that new, but the way you use it has grown exponentially in the last 5 years. But now we have the GPUs, and the processing in the computers are more efficient with this type of hardware that have the capacity to do many operations to multiply the matrix at the same time. So this is if you have a dedicated GPU for this, then it's going to be better. And to finish, I'm going to leave you with these recommendations for reading. They're in English, but these books were in the beginning. There were 2 more, and this has to do with interpretation of machine learning, especially for those neural network models. It's very hard to establish that this variable is contributing in this way with the results. So there are different specific methods to interpret it and not only say that it's a black box. It's possible to understand what's happening, but it requires of specific methods to do so. So I'm going to leave this information and the links so that you can read this if you're interested.